Okay, so this is a short video about using the swath mapping tool. I'm going to run a swath on some data that I've already processed. So I'm going to show you how to do that in this particular video. I'm working in a Python notebook. This video works inside the University of Edinburgh's notebook service called Notable. If you are working on Google Colab, you have to get lsdtopotools working first. So if you pick any of the lsdtopotools kind of example notebooks, you'll see near the top that you have to install a couple of things here. So you first install lsdvistools, then you start Conda Colab, and then you install lsdtopotools. If you're at the University of Edinburgh and you're using our notebook server, the lsdtopotools is already installed. Although vistools is not installed. So if I'm going to do this, say I take one of these notebooks, I can install this first. So I'll just do that for a second. That should install vistools. And then the next thing you can do is check if lsdtopotools is installed. So if you just run lsdtt basic metrics, you put the exclamation point in front, it will print this out if it's installed. It says fatal error because you haven't given it a parameter file, but this means it exists on the system. So the next thing is that I have downloaded some data. This is data that I've processed previously that comes along with a course that I'm running. So in this data, I'll just show you this data over here. You download a zip file and you need to unzip it. So you can, with your favorite zip program, you can unzip the thing here. And then there's a bunch of other bits that get unzipped. So it started with a NV build file, so it's in the correct format for lsdtopotools. And then I also churned out curvature and slope and a hill shade and area and stuff like that. So all that needs to get copied into your Python environment. So that could be on your Google Colab session, or in this case, I've copied it across to a notable file system. So this is the service we use at University of Edinburgh. Okay, so what I want to do is I want to make a swath, but I want to make a swath not over the actual elevation, but I want to do it over the curvature. So how do I do that? So first of all, what I want is I want to get the ends of the swath. So I kind of have done this already on one occasion, but let's do it somewhere else in this landscape. So I don't know, let's pick an area to do the swath. So I'll draw a transect across from here to here, let's say. So we'll start here. That's the first part of the swath. Actually, back up. Where do I get this bit of line? So if you go into the lsdtopotools examples, there's a swath plot example. So it will go through making a swath. In this case, I don't need to get the data, so we can skip the get data part. Now we have this command, which writes the file that has the ends of the swath together. So that's where I'm starting from. So I just need to replace, I copy this in to my notebook, and then I just need to replace the ends of this. So here's my first end, and my second end is going to be over here. Okay, so just pasting that in. And I execute that. And what happens? Oh, where did it go? It's up here. So here we go. That writes this file with the ends of the swath. I don't need this. I've already done that. Oops. Click on this. If you're wondering what I'm doing, there's shortcuts in the Notable where if you click a cell, if you hit DD, it deletes a cell. If you hit A, it makes a cell above. So if I hit A, it makes a cell above. If I hit DD, it deletes the cell. Okay, so the next thing, we want to make the swath. So where does all this stuff come from? It comes from this example. So run the swath tool. So actually, I'm going to copy this across here. So let's make this above. I copy that across there. Now, this is from this other file for the other example over here, but your file names are different. So there's no source name in this. The file name is this thing, the curvature file name. So EL study curve. So here, we already have the hillshade. I don't need that. Down here, I need the write and read prefix, but none of that stuff is needed. I'm just using the full name here. And then I've got all this other stuff. So calculate swath profile. Yes, calculate the swath along a line. Yes, the other option is along a channel, but you don't want that. For this example, swath point CSV, we just wrote that. And then I have a couple of other things that need to go in here. So what is all this stuff? The swath width is how wide that swath is. It does what it says on the tin. The swath point spacing. So along the swath, you have points along the swath. I'm going to actually reduce this. So it draws a line and then it separates it into points. And it then measures pixels perpendicular to those points. And then it has bins. So it aggregates the data from the bins, and that allows it to collect statistics about this. So that's what the swath point spacing and the swath bin spacing are. Finally, this is actually the second time I've made this video because the first time it did something funny and didn't work, and I had to realize what it did later. But what it does is the default is to run a little routine inside lsdtopotools, which is called remove C's, which gets rid of things with negative elevations. However, this is using a curvature data set, not the elevations. And so we need to make sure that it can cope with negative elevation. We won't switch those to no data. So I need to have this little keyword, minimum elevation, and curvatures kind of run from negative 0.1 to positive 0.1, maybe a little bit bigger. Just to be safe, I've set the minimum elevation of -5. Okay, so that is the command that I'm going to run. Actually, that's just a repeat of this command. I can delete that. Okay, and now I run this. So that will think for a bit, and we'll go through running the whole thing. And in the end, I should have a new swath CSV. I can plot that. I need to import something here. So there's this command here, which I import. Again, this comes from this worksheet. So I'm importing this thing. Import this thing. Okay, that should be imported. And now I can just plot it. So this thing, you don't really need to change this very much. You can increase the resolution and make it wider if you want, but it makes a PNG. So I can use this command, again, copied from this other notebook to show the swath profile of the curvature. And here is the swath profile of the curvature there. Now, you'll notice the formatting on the bottom is a little bit, well, it's not very good, is it? The reason for that is that typically I have these swaths that would go across mountain ranges. So you'd have many kilometers, but this one, it's sort of less than a kilometer, the swath. So the labeling on the automatic figure is not amazing. However, if you want to look at the swath, so if you go into the file, this CSV is the actual swath file. So you can export that. Oops, nope, that's the ends of the swath. Where is the actual swath? I need to refresh this. Give me 1 second. There it is, curved swath. There it is. So this has the CSV. It's got the distance along the swath, the mean elevation, the minimum value, the first quartile, all this stuff. So that information you can then use to plot. So the mean, it says elevation, but actually in this case it's the curvature. Then it has the minimum, the first quartile, the median, the third quartile. So you can use these minimums, quartiles, medians to draw your swath as you wish. So hopefully that allows you to create your own swath with some data that's not necessarily elevation data that you've processed somewhere else. Okay.